Hello everyone. Today we'll talk about the problem smallest string starting from leaf. We're given a binary tree where in each vertex we have a letter. In this case they are represented as numbers between 0 and 25 inclusive. And we have to, among all the words that can be created by concatenating the letters going from a leaf to root, return the lexicographically smallest. So the first letter has to be as small as possible, then the second letter, and so on, and finally a prefix of something is smaller than that something. So here we're given an example. Of course, the tree doesn't have to be a full binary tree, so some of those words can be longer, some can be shorter. Of course, it's not like a shorter word is always better than a longer word, because if we get a word, let's say like BC, and add an A to its beginning, then it becomes a smaller word. That's how lexicographical sorting works. And there may be some ways to solve this problem with some ideas, some knowledge of lexicographical sorting, but today I'll just show you the solution that simply implements this process, selects the smallest string, and that will suffice to solve this problem. Here we can see side by side two very similar solutions. First on the left, which is the most naive perhaps, we'll just maintain a list of all the strings we've encountered along the way. So in order to create all those strings, the simplest way is probably to just do it recursively. So we'll have a function which will run at our root, and whenever possible, it goes to the left, it goes to the right. And if it's not possible, that means we're in a leaf, and so our currently maintained string has to be added to the list of all possible strings. So we just create that string from our list, which we have to reverse because we want to read from bottom up and not top to bottom. The way that I prefer writing simple backtracking algorithms. Of course, you can pass arguments to functions, but I like to maintain that single current value. And when we, in this case, append our current letter to that value, then we have to remember before returning from our function to remove it from the current value. And of course, since we're being asked to just return the smallest string, then we don't have to maintain all of them and then sort them and return the first one, or find the minimum in that list. We can just maintain that minimum along the way. So this is essentially the same solution. However, whenever we are in a leaf, so we have a new string, we just compare if it's the first string we've seen, or if it's better than the previous one, and if so, we remember it, and then that is what we return.